Now the third operation is difference of sets. The difference of two sets, say A and B, is the collection of those elements of A which do not belong to B. It is represented as A minus B, or it is denoted as A minus B. So let us take an example. If A is equal to 1, 3, 5, 9, 11 and B is 2, 4, 5, 10, 11. Now the difference of the two sets will be those elements of A which do not belong to B. See the elements of A which do not belong to B. 1, it does not belong to B. 3, it does not belong to B. 5 belongs to B. 9 does not belong to B. 11 belongs to B. So we have to take only those elements that belongs to A, not B. So the difference of the two sets A minus B will be 1, 3, 9. Okay, what will be then A minus B? B minus A? B minus A will be those elements of B which do not belong to A. Okay. Now, see the elements of B. 2, 4, 5, 10, 11. We have to take the elements of B that do not belong to A. Does 2 belong to A? No. 4? No. 5? Yes. Cancel. And 11. So we have to write it as 2, 4, 10. This is the difference of two sets. Let us take another example. If A is equal to A, B, C, F, G and B is equal to D, F, I, K. These are the two sets. Then what will be the A minus B? Collection of those elements of A that do not belong to B. See the elements of A which do not belong to B. A belongs to B? No. So A. Does B belong to B? No. So B. Does C belong to B? No. That is C. F and F is common. So it will go off and we have G. Now what will be B minus A? B minus A will be set of those elements of B which do not belong to A. D, it is not in A, so D. F is in A, cancel. I and K. This is the difference of two sets. Now we can represent the difference of two sets in set builder form as A minus B. We know that it is the collection of those elements of A that do not belong to B. So the set builder form will be X such that X belongs to A but X does not belong to B. Okay. In order to show the difference of two sets diagrammatically, we will know that it is the collection of those elements. So if we have to write A minus B, so it is the collection of those elements of A which do not belong to B. That is, there is no intersection between A and B. So what we have, this will be the diagram of A minus B. See, we are considering only the elements of A that do not belong to B because this portion is common. So we have to erase it. It will be the difference of two sets. Another one is that is the complement of a set. So what is the complement of a set? It is the collection of those elements those elements in the universal set which do not belongs to A. Belongs to A. It is denoted by A bar or A complement. Okay. Now, in set builder form, we can write it as A complement is equal to X such that X belongs to U and X does not belong to A. In other words, we can write it as A complement is equal to U minus A. Diagrammatically, we can show it as, if this is a universal set and it is set A, it means we have to write the elements of U that do not belong to A. So what will be the diagram? This will be A complement. This is A and the A complement will be the shaded portion. Let us take an example. If U is equal to 1, 2, 3, 4, 5, 6, 7 and the set A is 1, 3, 5. So what will be the A complement? A complement will be U minus A. That is, I have to write those elements of U that do not belong to A. Or in other words, I can say that I have to cancel out those elements of U which belongs to A. What are the common elements? 1, 3 and 5. So I have to write the elements of U, that is 2, 4, 6 and 7. Let us take another example. If U is equal to N, that is set of natural numbers 1, 2, 3, 4, 5, 6, 7, 8, so on, and A be the set of odd numbers, then what will be the A complement? U minus A. That is, I have to write those elements of U which do not belong to A. In other words, I have to cancel out all odd numbers from U. That is 1, 3, 5, 7 and so on. And the remaining set will be 2, 4, 6, 8 and it is set of even numbers. Got it? Okay. Now the fifth operation is symmetric difference. Let us first define it. Let A and B be two sets. Then this symmetric difference of A and B denoted by is given as, it is defined as A minus B union B minus A. Symbolically, we can write it as in set builder form X such that X belongs to A and X does not belong to B, or X belongs to B and X does not belong to A. Okay, it is the set builder form of the symmetric difference of two sets. Now it is shown in the Venn diagram as, suppose if this is a universal set and this is set A, this is set B. Okay, then what will be the symmetric difference of the two sets? The shaded portion, this one. It means we have to write all the elements of A and B without the common elements. So the symmetric difference of two sets is the collection of all those elements of A and B without their common points. Let us take a simple example. If A is equal to 1, 2, 3, 4, 5, 6 and 7. B is equal to 3, 4, 5, 6, 7, 8, 9. Now let us take first A minus B. We have to write the collection of those elements of A which do not belong to B. 1, it does not belong to B. 2, it does not belong to B. 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. We have to write only the elements of A that do not belong to B. There are only two elements, 1, 2 that do not belong to B. Now, what will be B minus A? Collection of those elements of B that do not belong to A. So we have to write the elements of B. We have 3, 3 as common, 4, 4, 5, 5, 6, 6, 7, 7. But we see two elements in set B, that is 8 and 9, that do not belong to set A. So what will be B minus A? It will be 8 and 9. Now let us take the symmetric difference of the two sets denoted as, it is equal to A minus B union B minus A. That is equal to, what is A minus B? 1 2 union 8 comma 9. So the union will be 1 2 8 9. So what we have done, we wrote only those elements of A that do not belong to B, and we wrote those elements of B that do not belong to A. Look, 1, 2, these two elements do not belong to B. 1, 2. 8, 9. These elements do not belong to A, so we wrote 8, 9. Okay, this is the symmetric difference of two sets.